Okay, welcome back. So today will be the next lecture in our series. This is the trickiest one. I wouldn't say the trickiest one. It just has lots of information that you actually need to digest on this. Okay, so you will need to switch your brains on a little bit for this one. It's all about the networking that we will use in our cloud. Okay, so if you remember from the diagram in the beginning, a cloud needs to have two types of networking. It needs to have a service network that allows everything to communicate with each other, and then it needs to have a virtual machine network that allows the virtual machines to communicate with the outside world. For us, there is no need for service network because everything is running on the same host, everything is running on Prometheus itself. So we only need to have the virtual network for our virtual machine so that they can get access to the outside world. At the moment, we do this in a very simple and very ineffective way. We have created a bridge that's called BR0 that connects our virtual machine to our host, and every time we shut down our virtual machine, the BR0 goes down and wreaks havoc in the system. Okay, so this is only because we're building it as a test environment and we don't care. It's only a temporary solution. What we will do is we will destroy that bridge and we will build ourselves a set of fancy new bridges by using some new software that we will install on the system. That software is called OpenVSwitch. Alright, so it's a set of networking drivers developed specifically for OpenNebula so that you can create virtual network cards in a cloud environment and you can customize them in any way you want. So in order to use this, we need to, first of all, install it. Now to install OVS, the first thing that you need to be careful about is the version that we're using. We need to use specifically version 2.15. There are newer versions available out there, but those versions are more compatible with newer versions of OpenNebula, which in turn are more compatible with versions 8 and 9 of Red Hat Enterprise Linux. So because we're using version 7 of CentOS, we need to stick with these versions of this software. Now, once you download this, if you actually click on this, it is a link and it will take you to the file itself. You will download this, and this is a tar.gz archive. Okay, so this is a Linux zip file. So what you need to do with this one is it will go to downloads and you will need to extract it. You can extract it either using the commands tar-x in a terminal, or you can double click on it, it will open with the archiver, and you can just drag and drop everything outside onto the downloads folder. You will then need to open a terminal, and I would like that terminal to be inside that OpenVSwitch folder for the rest of this lab sheet. Okay, at least for the installation process of this, all of the commands need to be executed inside that folder. Okay. Because the commands boot, configure, make, dist, for example, they will not run if you're not there. And also the copy commands that we'll need later, they will also not run if you're not inside that folder. So the easiest way to do this is download the archive, extract it, go into the archive itself, right click on it, open terminal, and that will open a terminal inside the OpenVSwitch folder in there. Once you have that, you need to install some prerequisite libraries on the system. The method of installation is what we call an installation from source. So we're downloading the C header files and everything else of the program itself, and we're going to compile the executables for this particular version of Linux that we're using. And in fact, we will create ourselves an RPM of this that is tailored specifically to our system. Okay. You need to install lots of stuff. And the easiest way to do this is to have the browser and the lab sheet open inside your Prometheus virtual machine, and then just copy each of these lines and paste them into a terminal. You could do this in one go. However, you cannot copy and paste all of this in one go. The Linux terminal wouldn't let you do that. And that's why I've split it into 4 lines. All right. So do them line by line, make sure that they all execute correctly and you don't get any the system complaining about anything at the end of it. Okay, it doesn't tell you that, package not found or whatever. And once that process has completed successfully, you can then type ./bootsh. This is a shell script, and it will start the process of creating all of the files that you need in order to install something from source in the system. So you then run the configure command, and then you run the make dist, make distribution command. They will run for a while, but they don't take too long. They are relatively quick commands. Okay. Screenshots, you don't need to take screenshots of the terminal scrolling text. All right, there's really no point in doing this. You could be very fancy and take a video of it and stick the video in the logbook, but please don't do that. Yeah. All right, so once this process is completed, you will then have a distribution that's called Open vSwitch 2.15.0 whatever. You will need to copy this. You need to copy it into a directory that you will create. So you will create a directory structure with the make dir command, and you will create a folder called RPM build, and inside it, it will have sources, build, RPM, specs, and SRPMs. So this command will create the folder and its corresponding subfolders all in one go, because Linux is awesome. Once you do that, you then need to copy the files to the correct location. So you copy the Open vSwitch 2.15.0 onto the RPM build sources folder. Okay. If you have that in place, then you need the next command, which is RPM build -bb Open vSwitch.spec, and that command will take a while. All right. It can take more than 5 minutes actually. All right. Lots of text will scroll by and everything, and hopefully it should complete without any glitches. If it does, please call us. And hopefully it glitches straight in the beginning, because the only way that this can go wrong is you are not in the correct folder when you're running this command. Okay, so just make sure again that you are in the downloads Open vSwitch folder when you type all of these commands. Once this happens, you need yum local install and then the name of the file that you're installing. So essentially, you're locally installing the RPM that you just built, but instead of doing RPM -I and the name of the RPM, you're doing yum local install and the name of the RPM, so that again, if any dependencies come up, the system will go and fetch them online automatically on its own, so you don't need to worry about it. Okay. Once that happens, then OVS is installed, and you can do systemctl enable Open vSwitch so that it starts every time you boot up your Prometheus VM automatically, and then you can do systemctl start Open vSwitch to actually start the service running. In order to see if this all has been successful, what you need to do is you need to use the command OVS vsctl. The easiest thing to do actually is type OVS vsctl show, and that command will show you which version of OVS is installed and what modules it has configured on the system at the moment. It should have nothing. You haven't configured any network cards, any bridges, any ports, nothing yet. All right. Once you do this, you have the software installed, and it's time to play around with the software itself and to create the network cards that we need to create in our system. The first network card that we'll need to create, we will call it VMnet28. So once this is all finished, we should have a network card for network 28 that is a bridge that is directly connected onto ENS33 and hence gives you access to the outside world straight away. And you will also have network cards 30, 31, and 32 that will belong to subnets 148.197.30 dot whatever, 31 dot whatever, 32 dot whatever. The whatever part of that sentence is a lecture in and on its own, and I will explain this much more next week. All right, so to begin with, for the next time you come into the lab, I really care about you building VMnet 28, 30, 31, and 32, but I don't want you to configure IP addresses and networking information for them. If you do that, you're progressing fast enough in the lab and you're happy with it, then I can explain it to you in the lab. In fact, I will show you the guide on how to do it. Okay, I won't go into too much detail explaining why it is like that. So if you feel up to the task, you can try and configure all the network cards, but if it doesn't work, don't panic. I will explain everything next week as well in great detail about this. So, what do we need? We need to configure OVS itself to know about our VMnet28 bridge, so it needs to know about our Net28 network card and what that connects to. So OVS creates bridges, and the bridges need to have ports. The ports on the bridges are the endpoints of the bridge on its side. In this particular case, we will have Net28, okay, and we will have ENS33. So other than the add bridge VMnet28 command that we need, so we're telling the system build me a bridge, call it VMnet28, we will add a port that's called Net28 on the bridge VMnet28, so that's going to be the one side of the bridge, and that will be set interface Net28 and type internal, and then we'll add another port which will be port VMnet28 ENS33, which is the network card that should already exist on your Prometheus virtual machine, and it is where your Net28 network card on the system will connect to. This command will give you an error, and it's fine. Okay, it's expected. The reason why it will give you an error is because your networking configuration at this point is not the default networking configuration. You have a BR0 in place. We need to undo this. All right. So we need to find our IFCFG BR0, and we need to create a network card called Net28. You can replace them, you can do whatever you like. At the end, you need to end up with those two files. Okay, so ENS33 will pretty much look the same as it did before, but BR0 will now be replaced with Net28, and it must look like this. Okay, I would recommend the way to do this would be to take your IFCFG ENS33 network card file and the BR0 file from etc. sysconfig network scripts, cut it and paste it in your documents. So keep a backup of them in there and make them disappear from the config folder. You then create two new files from scratch, copy and paste the contents from this lab sheet onto there. The best way and the safest way to do this is for the lab sheet to be open inside your Prometheus VM, not on your computer. Okay, as I said, especially in this lab sheet and on, it's much better to have everything running inside the virtual machine rather than outside and copying them inside the VM. So, if you copy and paste the contents of those files, make sure you don't leave these as XX. Yes, if it's XX, you need to change to whatever IP address corresponds to your computer. All right. I will update this file as well because the DNS server is also wrong here, and I will make a bet with myself to do this today. So once you do this and once you place the files in their location, you should either be able to do service network restart. If that doesn't work, you can restart the actual Prometheus VM itself. And then once that happens, when you type ifconfig, a Net28 should come up as a network card that has the correct IP address on subnet 28. And ENS33 should come up with no IP addresses inside it. You should just be present but blank. And you should have full internet access. And when you do that, if you type OVS VSCTL show, this should now come up without any errors. Okay, so you shouldn't get an error next to this if you've done everything correctly. All right, so when you're building the VMnet28 bridge on OVS, it will error out because it's reading the wrong configuration files from your etc. sysconfig network scripts folder. But once you replace those folders, then it will run correctly. Okay, now we need to repeat this process in order to create the bridges VMnet 30, 31, and 32. So you need to type in these OVS commands in order to create the VMnet bridge, and then you only need to add one port onto that bridge and call it Net30. We'll leave the other port of the bridge open-ended, and you'll see later on why. All right, so you need to create 30, 31, 32. By the end of this process, your OVS VSCTL show should show 4 network cards, 4 bridges rather, connected to 4 network cards. Okay, VMnet 28, VMnet 30, 31, 32. And your ifconfig once you create the files for them in etc. sysconfig network scripts as well, should also contain 4 network cards. It should contain net28, net30, net31, net32. Okay. If you have an ifconfig that has all 4 network cards and you have an OVS VSETL show that has all 4 bridges, you are done with OVS. Okay, it's configured correctly. Now, in order to do this, you need to know what IP addresses to use for all of your network cards. The VMnet28 or net28 is easy and straightforward. Okay, it's whatever you've always been using so far. So whatever your Prometheus is, that's it. Okay. However, the networks 30, 31, and 32 are different. If you look onto Moodle, you will find this lovely file that's called a2.net subnets. Okay. We need to find a way for all of you to use networks 30, 31, and 32, but make sure that nobody has the same IP address as anybody else. All right. So the network that we're using, anything that I say for network 30 applies exactly the same for networks 31 and 32. Yeah? So let's say, for example, I'm working on computer Hunt. All right. This file tells me that if I'm on Hunt, I can use a network address of 30.44, I can use a broadcast address of 30.47, and my usable IP addresses are 30.45 and 30.46. Okay. In the same way, if I'm working on 31 or 32, it's exactly the same range of addresses, but on subnets 31 and 32 instead. All right. So, what do we do with those? The network cards that we create on our system, net30, net31, net32, we will need to create a configuration file for them, ifcfg net30, net31, net32, and they will look just like our net28 looks. Okay, they need to have IP addresses, default gateways, and everything else. So the IP address for my net30 would be 148.197.30.45 because I'm working on Hunt and my first usable IP address is 45. Yes, 46 is a perfectly valid IP address to use here. You have 2 addresses, you can use either of them, but please, please, please have mercy on my soul and use the first address. Because I have a small chance of remembering the addresses. Alright, so if we want our troubleshooting to be easier, I need to assume that you will use your first usable IP address on Prometheus, and then your second usable IP address on the virtual machine that you will build in the cloud that will utilize that network card and will connect to that network card. Okay, so at the moment your VP0 virtual machine in your cloud is using a bridge that's the second level bridge on network 28. Other virtual machines that you will create for the last lab sheet will need to use networks 30, 31, 32. So the way that we allocate those 2 addresses that we have here is we allocate the first usable IP address onto the network card onto Prometheus, and we allocate the second usable IP address onto the virtual machine inside the cloud that's using this IP address. How do we do this? The first usable IP address is the ifconfig file on Prometheus. The second usable IP address is created inside the cloud itself with the network card settings when we create a new network interface in the cloud itself. And then we start up the virtual machine that is supposed to use that net30 network card, and we configure those IP addresses in there, and it's done. So if I'm inside the cloud and I'm using network 30, my address will be 30.46, and I should be able to ping 30.45 because that's the network card that I'm connected to on Prometheus itself. Okay, so where does this come from is something that I will explain in much more detail in the next lecture. All right, all you need to worry about now is if you get to this point and you really want to configure your network cards 30, 31, 32 next week, then give them those IP addresses. And next week I will explain why in great detail. All right. So if we go back to the lab sheet, we have created our network cards. We have our net 30, 31, 32, and then we need to sort out the networking in the cloud. So we need to go inside the cloud itself, and we need to go to infrastructure, virtual network cards, and delete any network cards we have there at the moment. Okay, you will have a BR0 network card there, or an ENS33, or if you created a random network card for this third lab sheet that we were doing today, and you called it whatever, you need to delete those network cards. In order to delete those network cards, they must not be used by any template that's currently instantiated. This means that before you do anything in the cloud, go to instances VMs, click on the little box next to your virtual machine that's running, and then click on the scary red button with a bin on it and bin it. You won't lose the contents of the virtual machine because the hard drive is persistent. You will deinstantiate the virtual machine, so it will not exist in your cloud anymore. It will only exist as a template, which you can go to that template, in fact into its settings, click update, go to networks, and remove the BR0 network card from there as well. Hit save, and you're done. Only then can you go into the networks tab and actually delete all of the network cards that you have. Once you do that, you will need to create 4 new network cards in there. Follow the instructions here, give them the correct IP address that will correspond to the virtual machine that you're building. Yes, bridge VMnet 28 just as you had with BR0. Essentially, you're just renaming the network card. And then create network cards VMnet 30, 31, 32 according to the instructions of the lab sheet. Use the second IP address as the IP address in there. And the only detail that you need to worry about here is the gateway itself. So if you're using, let's say, 30.46 as the IP address for the virtual machine on hand, what should your default gateway be for this? The rule is always the next IP address you see on your way towards the internet. So if you're configuring 46 and you are inside the virtual machine in the cloud, that virtual machine connects to Prometheus onto the net 30 other side of the bridge, and that has an address of 30.45. So for your virtual machines, for your settings inside the cloud, the default gateway is the first usable IP address of your network. And that's it. Things get funkier when you will actually be configuring this file for networks 30, 31, and 32. Because when it asks for the default gateway here, the gateway will be the IP address of your Prometheus VM. Your 28.51, 52, up to whatever it is, 98. All right. Because again, your net 30, 31, 32 network cards on Prometheus go to the internet from the net 28 network card that sends the machine to the outside world. That net 28 has a default gateway of 28254, which is fine, it's on the same network and everybody's happy about it. Okay, however, this is a slightly customized setup because later on, in order to give access to our network, to all of our subnets, we will set up routing. So we will configure our Prometheus VM as a software router for our cloud. Okay, and that's why the gateways are like that essentially. So once you configure all of the IP addresses, default gateways, DNS servers, and everything else, then your job is to allocate one of these network cards to one of your virtual machines. I recommend you make your life easy and allocate VMnet 28 back onto the VP0 that you already had running. So go to the template, update the template, add the network card there, and then instantiate this, give it an IP address of 28.100 and whatever, and ping google.com and you should be able to do this straight away. All right. Essentially, it's the same networking environment as before with different names. The BR0 is now called VMnet28. Woohoo. All right. In the next lab sheet, which is the final lab sheet as well, you will need to create more computers inside your cloud, and then you can use all of the other network cards that we have, and you can actually set up routing in order to give internet access to all of these other network cards as well. Because from anything on subnet 30, 31, 32, you will not be able to get access to the outside world, because in order to jump across different networks, we need routing. Yes, we need routing. So, at the end of this lab sheet, you can set up OSPF as a routing protocol, and you can do this using Quagga, which is a routing daemon that is used in Red Hat Enterprise up to version 7, because from version 8 and onwards this changed to FRR, whatever it's called. It's the same thing anyway. All right. So again, they just renamed it and added more capabilities, which is hurrah for them. And if you fail the unit this year, you'll use that one next year. Anyway, so yes, so you need to set up routing. The way to set it up is fairly straightforward. I will give you example configuration files. There is a zebra.conf and an ospfd.conf, and I will explain exactly what they should be next week. All right, you stick them in the etc. Quagga folder, you run everything, and hooray, it works. All right, so once you have all of this completed, then you have all of your networking infrastructure completed on Prometheus, and you can run up to 4 virtual machines inside your cloud on 4 different networks, with 1 VM being bridged and 3 VMs being on what we call a host-only environment or a custom network environment. Okay, they will be on different subnets. The limitation of the 4 virtual machines is not just going to be a problem because of our IP addresses, it's going to be a problem because of the available cores in our system and resources in our cloud. Okay, remember you're building a cloud inside a virtual machine on top of a host. Things will become slow eventually. All right, and we figured that you can pretty much run 4 VMs with a graphical user interface, but even that is a bit sketchy at points. All right. If you have previous experience and you can set up virtual machines in terminal mode only, you can run as many as you like. You can give them like 1/10 of a core of a CPU, give them 256 megabytes of RAM, and let the thing loose on the cloud. Make 50 of them if you like. All right. It all depends. It all comes down to the amount of resources that we have in the system. And this is also one of the reasons why we don't allow remote connections in the lab anymore, whereas we did up to last year. Students would connect remotely during the labs, fire up their clouds, and then havoc would wreak in the lab. Okay, so when you're working on your computer, you know that you're the only person working on that computer, and you can use all of the available CPU cores and memory in your system, and that's it. All right, so I will stop here. For next week, when you do your first, when you touch this lab sheet for the first time, what I definitely want you to do is I want you to build all of the virtual network interfaces on OVS, and I want you to get as far as you can with the network cards themselves, but don't worry. I expect this lab sheet to last a minimum of 2 weeks. Okay, we are still in February, and there's only 1 lab sheet, albeit a very big lab sheet, left. All right, so don't worry and panic about progress. The deadline for the logbook is sometime in May. 19th? Okay, so lots of months. All right. Make sure you take all the screenshots that you need for your logbook. Make sure you understand what's happening when you do it. And make sure you explain in the logbook not only what we're seeing in the screenshot, but most importantly, why you did this. All right. This is what will get you marks when we mark the logbook, not the progress and an infinite number of screenshots. All right, I've had logbooks in the past that had 120 pages and I gave them 60. Yes, the glorious B, because they explained almost nothing. Okay, so the point of this is for you to learn. All right, it's a complicated process. Things will go wrong. Try to remember what needs to be running for other things to run. So for example, when we're doing the OVS installation, remember that when you do this the first time, it will error out. All right. So little details like that, keep them in mind and don't panic and you'll be fine. And of course, ask us questions. All right. Any questions about all this? Okay.